Why an alternating electrical quantity is always sinusoidal? Why not other shape? So this is the topic of this video. The electrical quantity means voltage or current. Alternating electrical quantity means the voltage and current periodically changes their magnitude and their direction with respect to the time. Okay, with respect to the time. So alternating electrical quantity, we can consider, we may say square also alternating, rectangular is also alternating, triangular, trapezoidal, short-tooth, sine wave, everything is, whatever I'm showing here, everything is looking like alternating. But compared to this shape, we are considering only the sinusoidal shape in an electrical AC system. There is a uniqueness in a sinusoidal AC system. That is why we are using all over the world alternating AC is sinusoidal. Hence it is universal shape. Hence it is called as universal shape. And the sinusoidal, to explain the uniqueness of sinusoidal wave shape, I am going to take four mathematical approach: addition, subtraction, differentiation and integration. Before seeing the reason of choosing these four mathematical approach, you have to see this tabular column. Here, that is any electrical circuit, there will be a resistive component, inductive component, capacitive component. Along with that we have supply, right? So these are all nothing but load and supply also there in any electrical system. And if you are analyzing the voltage and current for that respective element, V equal to IR and I equal to V by R. And for the inductance, VL equal to L into di by dt, and IL equal to current IL equal to 1 by L into integral V dt. And for the capacitive element, voltage is V is equal to 1 by C integral I dt and IC equal to C into dV by dt. Okay, so these are all basic things we know already. Here, to find the voltage and current across that individual element, and we are using differentiation and integration, right? So generally we are using this. Okay, and the reason of using, so that is why we are in mathematical approach I have selected differentiation and integration. In electrical system, any kind of load, for example in our home we are using a mixie grinder, fan, refrigerator and heater, everything we are using, right? So all the loads are consist of resistive element, inductive element and capacitive element, right? But practically resistive load is possible. Okay, resistive load practically is there. Example of pure resistive load is water heater, bulb, tube light, okay, hazer, load which is getting electrical energy, and by using that electrical energy which is going to utilize the electrical energy in the form of heat energy, that kind of load is coming under pure resistive load. And pure inductive load, pure capacitive load is practically impossible, because if you are considering inductance or capacitance, okay, capacitor, if you are considering inductor or capacitor, the inductor is made up of some material. So every material has its own resistance. So while seeing about the inductor, we have to consider resistive effect of that element and that inductive nature. Okay, so RL. Okay, and capacitor also made up of some material, so there will be resistive effect and capacitive effect. So R load is practically possible, RL load is possible, RC load is also practically possible, and RLC load is also available practically. Okay, the RL load example we can say motor, transformer and arc furnace. So to explain in depth, I am going to consider multiple element like RLC electrical circuit to explain the importance of addition, subtraction, integration and differentiation in the electrical system. So now we have to see RLC load. In RLC load have taken RLC circuit have taken R, L and C. These three elements connected in series with the supply voltage V. It is a closed circuit, so it causes current I, and so the total voltage is going to share by this element. So voltage across this resistor is nothing but VR. Voltage across this inductor is nothing but VL. Voltage across this capacitor is nothing but VC. So the total voltage is going to apply across this all element, right? So hence we can write the equation that supply voltage V is equal to, according to KVL, VR plus VL plus VC. Instead of this equation, we can write in terms of current IR plus L into di by dt plus 1 by C into integral I dt, right? Here the summation approach is there, differentiation is there and integration is also there. And if you want to find the voltage across the individual element, that is if it is unknown, okay, then in that case also we can find by using subtraction symbol. See, subtraction approach. For example, I am considering VR is unknown and VR is equal to V minus VL minus VC, right? Here we are using subtraction approach to find the electrical quantity, right? So anyway, we are going to use addition, subtraction, differentiation and integration to find the electrical quantity in electrical circuit. So while doing this kind of mathematical approach, our wave shape nature should not destroy. So to analyze that, I am going to use these four mathematical approach in all kinds of wave shape, right? This continuation is given in part 2. I have given part 2 link also in the description box. So you have to see that and you will get complete idea. Thank you.